Welcome to the first episode of the Brevity Technical Webinar Series. My name is Gye Simkin and I'm Large Project Lead and obviously have difficulty at times starting a webinar. So this first episode is on compliance pathway for seismic restraints. Let's kick into it. I'm not sure if Matt got up to this bit, but we are using Slido for this presentation, which is pretty cool. It allows a bit of interaction for this presentation, and so I suppose if you can give it a go now, try use the QR code to log in, or use the slido.com and the code shown on the screen there. And as you are doing that, a screen should pop up with a poll. So just as a bit of a test exercise for using Slido as well, why don't we try this poll, which is, what's one word that describes the current state of the construction industry in New Zealand? So some are coming in as we speak. Not raining, that's good. Competitive, definitely. Inefficient. Good to know I've got at least 3, now 4 people online. Messy. That's an interesting one. Growing. All right, well, Slido's definitely working. Difficult. Yep. All right, well, hopefully after there's a good one. Hopefully after this, some of the difficulties in the compliance pathway will at least be answered. I'm not sure if I can help with the weather, particularly in Auckland. So let's start with seismic restraints. Seismic engineering is definitely a niche area that has evolved in New Zealand following earthquakes in the last 10 years, and then regulations also update. So prior to the 2011 Christchurch earthquakes, New Zealand didn't really design or enforce to the building code when it came to seismic restraints. And then after the earthquake happened, there was obviously a lot of damage to non-structural building elements, around $40 billion of damage to the building interiors, which has led to, in the last 10 years, a lot of changes to compliance. So in the commercial interiors area, some of the common seismic restraints that we design include your ceilings, your non-load bearing partitions, services, whether it be suspended, mechanical, hydraulic, electrical, or fire. There's also racking and shelving and floor-mounted components. So you need to install seismic restraints because it's required by law. That's essentially what keeps us in business. And it's also a good idea in an earthquake, obviously. So when we say required by law, seems like a fairly straight, simple statement there. Let's see what that means. So there's a compliance pathway, and it's a bit of a triangle where at the top you've got the Building Acts, and then following that what we call the building regulations, and then there's the building codes. So the Building Act is essentially the law of the land, and that refers to the building regulations. And it's in the building regulations that a building element is actually defined. So it's quite high up there in that triangle. A building element is described as any structural or non-structural element and assembly incorporated into or associated with a building. And included in that description, it specifically mentions ceilings and partitions and the ability for them to withstand earthquakes. Building regulations in the building code are often referred to, or I often see them as one and the other, because the building code is sort of like an appendix within the building regulations. It's in the building code that it defines what needs to be complied. So that's all written up, and it includes all the different clauses, clauses A, B, C, and following the building code, we have the acceptable solutions and verification methods. And these state how it's going to comply. The acceptable solutions and verification methods, these are released by MBIE, and there's quite a formal process with consultation with the BCAs, and these are treated as evidence that BCAs should accept these acceptable solutions and verification methods. And it's actually up to the individual BCAs to decide if they accept those solutions and methods. There's a few interesting ones. So, for example, NZS 4219, that is cited as a verification method, and it is used for the seismic restraints of engineering systems, specifically services. So that one is quite straightforward from a compliance pathway, at least where it's referenced anyway. But it can get a little more complicated with complying with this building code. So for seismic restraints, there's no acceptable solutions as such, and the acceptable solutions are predefined or predetermined ways to comply with the building code going up that triangle, and the verification methods are for the specific engineering designs, and engineers often use these for a compliance pathway, such as using NZS 4219. Let's jump to the next slide, and it keeps going. So breaking it down further, there's loading standards and material standards, and the job of the engineer is to figure out the load, and the capacity of the material needs to be greater than that. And there's often a fine balance between those loading and material standards. So hopefully the compliance pathway seems straightforward. It's when we look at various building elements, it can get slightly more confusing again. So it's quite common that you get a standard that is not cited in the building code. I suppose the main reason for that is a code cannot be referred to until it actually exists. So you can't refer to an imaginary standard that is still in draft form. So there's often a delay of up to maybe 2 years, yeah, an example is the New Zealand earthquake standard. So NZS 1170.5, Amendment 1 has been released but has not yet been included in the building code. So strictly speaking, 1170.5 Amendment 1 doesn't need to be complied with, but is it a good idea as an engineer? I think the answer to that is yes. So as you move up these compliance pathways, it does get harder and harder to update, and that's why often the standards are updated more often and the acceptable solutions are updated more often than the building code itself. What else is interesting to talk about here? I think ceilings is a good one. So the suspended ceiling standard AS/NZS 2785 is actually not cited anywhere within this compliance triangle. So 2785 is a standard that has been released. It has been consulted across the industry, and it's what is considered best industry practice. But it's yet to be, the plan there, I'm sure, is for that to be included as an acceptable solution. So you've got things like best practice, good practice and okay practice, but until the code catches up with all of this, it's a little behind best practice. As an engineer, we still use those standards, but it's not actually required by law. Partitions, the design of partitions is interesting because there's actually no specific standard to design partitions, but partitions were called out early up in the building regulations as a building element in the description. So most definitely partitions need to be designed for, particularly for seismic, but there's no current acceptable solution or verification method for designing partitions. Another example is the fire sprinkler standard, which is NZS 4541. That actually isn't cited in the B1 clauses of the building code, which is where the seismic designs fall into the structure. But it is referenced further on in the fire clauses of the building code. So I suppose what are we trying to say here? There's definitely a lot of pages, 1,547 to be exact. If you look at those standards and documents shown in that in the compliance pathway there, that doesn't obviously include other standards which engineers will often use. Common ones for us would be, the timber standards, fire standards, the services standards 4219 and the likes. So, 1,547 pages just gives you an idea of the difficulty to navigate a compliance pathway. Why does this matter to me? So two key takeaway points here, I suppose. The building code compliance is what is required to get consent. This can be different from contractual requirements. And it is important it's important to understand the difference. So an engineer could use, one pathway for compliance for getting consent, and then the build contract might say ceilings need to be designed to 2785. And then there's this possibility of a conflict between your main contractor and your subcontractor, and this is a building code law versus a contractual law, and it can be difficult to navigate. The second point here is that the building design at consent needs to be built. It's at the design relevant at the time. So if standards change between consent and build, that shouldn't require a redesign or a spec change. Some more key takeaways. There is a direct line from the Building Act to consent requirements for seismic restraint of interiors. Clause B1, VM1, verification method, does not currently cite the suspended ceilings 2785 standard, although I think it's fair to say that that standard is considered best practice. And the latest version of the building code often lags behind the latest version of the standards. So hopefully that has provided some interesting learning points, or maybe it's confused the matter even more. So let's jump into the Q&A session. So we've got about 4 minutes. I wasted a lot of that trying to set this up. Sorry. So if you log into Slido, you can post any questions you've got there, or you can like a current question that is already there, and we can go through it. So someone's put in a question: is the ceiling standard 2785 required for compliance to the building code? I think we've already covered that one off. So technically, no. 2785 isn't cited anywhere in the building code, but I'm sure it will be in years to come. Next question there is, do anchors for ceilings need to be seismically rated? That is definitely a hot topic at the moment, and it's something we actually did an article on maybe towards the end of last year. So I'll be able to post that in the LinkedIn follow-up. But to answer that one, seismically rated anchors into concrete, there's the whole C1, C2 discussion going around, which is that hot topic. And the reason why that question has popped up in the suspended ceiling space is because 2785 references the concrete standard, NZS 3101, and it's in that concrete standard. So there's like a compliance pathway, a link here. It's in that standard, which was updated about 5 years ago, the most recent amendment. There was reference there to European testing and design standards, which in turn references the need for C1 and C2 anchors. So yeah, I'll follow that one up with a link to our article we posted on seismic anchors for suspended ceilings. Another question, I wonder if more are popping in. For a fire-rated ceiling, we can't use a fixed float detail. Yeah, that's a very good question. So I suppose seismic engineers, we love to specify clearances and movement, whereas fire engineers, they don't like any gaps. They like things to be closed up. And so I'm not aware of like the formal resolution to that one when it comes to compliance, but the building code definitely considers seismic and fire as different compliance elements. And there's obviously crossover when it comes to certain details like fixed float edges. So I think that one, we're definitely seeing some new details coming out that are seismic and fire compliant. We'll have to share some of those ones that we're seeing on the market at the moment, and we can touch on that one a bit more. What else is there? Is racking mentioned in the building code? Another good question. So racking, as far as I'm aware, no, it's not included or referenced in the building code. But to get around that, councils will release their own like bulletins to say these BCAs will require a PS1 for racking. I see racking there as like your big pallet sort of racking structures. When you think of a pallet racking structure that's holding, let's say, 6 ton per bay, you would think that is part of the building as a building element. So yes, it should require a design, but again, that's just not referenced in the building code. So councils have their own requirements, and I suppose if you don't follow the council requests there, councils won't issue a certificate of compliance at the end for that whole building if you haven't issued your PS1 and PS4s if they're requesting it for those racking structures. Is there any more questions coming in? Let's just see. Can't see anymore. Wonder if it would pop up. If any more questions, do feel free to post more questions, and I'll be able to do a follow-up LinkedIn article clarifying these questions and any other ones people have. So I suppose let's wrap up the first webinar. The next one I will hope to start on time. Hopefully I don't have any more technical issues. But yeah, thank you for your time. I hope you got something from this, and see you next time.